This is our group member. First, we have Muhammad Anik Mukwi bin Irwandi. Second, we have Rosihanisa binti Basri. Third, we have Nurul Alia Nabisha binti Muhammad Nayan. And the last one is me, Melisna Jewel.
Research and literature review. What the principle of pre-stress and precast concrete? Concrete in which reinforcing steel bar are stretched and anchored to compress it and thus increase its resistance to stress. Pre-stressing is a method in which compression forces is applied to the reinforced concrete sections. The concrete can be visualized to have two compressive forces. Number one is the internal pre-stressing force, and number two is external forces. What the advantage of using precast and pre-stress component in infrastructure project? Number one is a reduction of cracking due to permanent pre-compressions. Number two is the better corrosion resistance. And number three, reduction of building weight, like a foundation savings. And number four, reduction of member thickness, material savings. Number five, architectural freedom of larger spans and irregular slab geometry. Reduction in construction time, like fast constructions. And the last one is no need of form work in case of precast. So this is a table of comparison of traditional reinforced concrete and pre-stressed concrete in terms of components, strength, economy, and construction time.
Now we go through to the design of the precast process concrete beam. As we know, the beam have a span 50 meter and the load is 25 kilonewton per meter. And first, we need to calculate the stress limit, compression FCI, tension FCM, compression FCI, and tension FCS, which is we get the compression 80 Newton millimeter square and 30 Newton millimeter square. And we get the tension FCM is 2.90 Newton per millimeter square and the FCS tension is 0.0 Newton millimeter square. Then we go to try the beam, which is the B is 300 millimeter and the height is 1400 millimeter. The area we get is 420,000 millimeter square. And now we go through to the section modulus Z1 equals Z2, which is we get the answer is 98.0 times 10 over 6 millimeter cube. And we go through to calculate the loading and bearing moment, which is the self weight is 10.08 kilonewton per meter. And go through to the initial moment, which is M, we get the answer is 283.5 kilonewton per meter. And we go through to calculate the total service load, which is W, which is we get the answer is 35.08 kilonewton per meter. And the last, we get for the service moment MS, we get the answer is 986.63 kilonewton per meter. As we know, the section modulus we get from the area of the beam divided by 6. For loading and bearing moment, we get from the area of beam times with the density of concrete. Initial moment, we get from the total of the safe weight divided by 8, and total service load we get from the total safe weight plus with total service load. And then the service moment we get from the total service load times with span and divide by 8. Now we go through to calculate the required section modulus, which is for the top fiber, we get the answer is 22.70 times 10 over 6, which is less than Z1 actual, 98.0 times 10 over 6 millimeter cube. And the answer is okay. For the bottom fiber, we get the 46.89, which is less than Z2 actual, 98.0 times 10 over 6 millimeter cube, and this is okay with standard. Now we go through to the standard section, which is we try use a PCA and beam M2, which is the top fiber. After we calculate that, we get the 22.44 times 10 over 6 millimeter cube, and the answer is less than Z1 actual, which is 36.64 times 10 over 6 millimeter cube. And for the bottom fiber, we get the 46.36 times 10 over 6 millimeter cube. And the answer, we get less than Z2 actual, which is 61.04 times 10 over 6 millimeter cube. And the Z1 actual and Z2 actual for the standard section, we get the Z1 and Z2 actual from the table.
Next, what is the building that we choose? Our group chose Menara Exchange 106 Tun Razak Exchange TRX. Exchange 106 is the embodiment of elegant sophistication and the nation ambitions with the single tower confidently reaching for the sky. It is a breathtaking building which makes its present feel. The skyscraper is the centerpiece of TRX. Malaysia's new financial district is designed to position Kuala Lumpur as a global financial hub. This building is developed by Mulia Group and also the tallest building in Malaysia by roof height. Next, what is the construction methods Menara Exchange 106 use? They use complete structural system, three-dimensional shape of the tower, plane rotation, column free and long span, and lastly is Islamic architecture. And what is the process of the construction? The first one is site investigation. It is works that gather the information needed to carry out the risk assessment. The second one is site work and setting up. It is about the practice of transferring the building design onto the land itself so that the workers can follow it during construction. The third one is foundation. The foundation of a building or civil structure is the element that connects to the ground. The third one is basement. A basement is a part of any building or structure typically constructed either entirely or partially below the ground floor or of the building. The fourth is wall and floor. The works that includes brick, block work, timber frame, solid concrete floors and beam. The last one is external wall. External wall works describe primarily the areas immediately surrounding the building. Next, how the precast techniques improve efficiency in Menara Exchange 106 Tun Razak Exchange. The first one is speed of construction. The second one is enhanced quality and precision. The third one is cost efficiency. And the last one is environmental benefits.
Now, let's move to discuss about the sustainability and cost analysis in structural design. There is two main topic about this topic, which is sustainability aspect and cost analysis aspect. In the sustainability aspect, there is the point of use of sustainable materials to reduce environmental impact. Next, there is focus on energy efficiency to lower energy consumption. And then there is also waste reduction through efficient design and construction practices. And the last one is life cycle assessment, LCA, to evaluate the long-term environmental effects. Meanwhile, in cost analysis aspect, there is life cycle cost analysis (LCCA) to understand costs over time. There's also initial cost versus long-term saving to balancing investment and maintenance. Next, there's value engineering optimizing design for cost efficiency. And the last one is incentive and regulation, ensuring compliance with sustainability policies. In this topic, there is a few benefits of sustainability and cost analysis. First, there is environmental benefits, which is to reduce carbon footprint and conservation of resources. Second, there is economic benefits, which is long-term saving and reduced maintenance costs. Third, there is performance and structural benefits, which is to improve durability and efficiency. The last one is regulatory and compliance benefits, about meeting sustainability standard and legal requirement. In the conclusion, this topic reflects both the sustainability and cost analysis play a crucial role in modern structure design. The integration of innovative materials and engineering techniques improves construction efficiency, balancing performance and durability and economic aspect help addresses infrastructure and challenges. Precast and prestressed concrete beams contribute sustainable construction by enhancing durability and efficiency.